Alright, welcome back guys. So this will be the second video on lesson 4.2, 4.3. In the previous video we introduced the addition rule of probability, and we did several examples so far, and we introduced the definition of mutually exclusive events. That's when two events have no outcomes in common or cannot occur simultaneously. And then we also discuss example of mutually exclusive events, and now we're gonna do two more examples that kind of touch on more on the addition rule of probability, so that way we get more practice. In example 4 here, we have a standard 52 card deck that we assume you guys will know what are in the 52 card deck. I think you can Google tell you what in a standard 52 card deck, and we want to find out the probability that a single card drawn from this deck, and we want to find out the chance that the card is drawn is either a diamond or a face card. Okay, so we can define these events. So event A will be the selected card or a card drawn is a diamond, right? And then let B be the event that, where the card drawn is a face card. Okay, we know the sample space is 52 cards, so sample space is 52 cards. Let's look at the possibility outcomes for A and B here. We know A in a deck of 52 cards are 13 diamonds, 13, and then in a deck of 52 cards, there are 12 face card. Okay, and if we want to find out the probability of A or B, then we're using the addition rule. Since it's a single trial, it's a single drawn here, so addition rule apply. So that's P of A plus P of B minus P of A and B, meaning are there any cards that belong to both events? Or can we draw a card that is both diamond and face card? We can have those cards. So diamond and face cards. So diamond and face cards. I think there are 3 of those. So you have Jack of diamond, and then Queen of diamond, and then Queen and King of diamond. So there's 3 of the cards are diamonds and face cards at the same time. So that's what we subtracting there. We don't want to double count because those cards appear in here and in there at the same time. So we got 13 over 52 for the chance of the card being diamond, combined with the chance that the card being a face card. So that's 12 52. But if we add these two numbers, we double count all the cards are both diamond and face cards, and those are the cards there. So we have 52. So that gives us 22 out of 52 as our answer. All right. So how do we know we're using addition rule? It's when we are conducting a single trial procedure, and that's right here, right? And then also is asking what's the probability of this event A occur or event B occur. So another word giveaway is the or word there. Okay. All right, let's go over the next example. Use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that the orders are randomly selected from those included in the table. If one order is selected, this tells us we're going to use addition rule. Find the probability of getting an order from restaurant A, or, right, or is another word that trigger addition rule, or an order that is accurate. So we have 2 events here. So an order is selected from restaurant A and an order that is accurate. So the way we read these contingent table is that, let's say if I'm looking at number 38 here, so 38 orders that belong from restaurant A or order from restaurant A, and those order are not accurate. So that's how we read the table, right? And then we have the sum columns, and then we have the grand total as well, right? So we have this. So what we can do is we can start adding these columns. So we have sum columns and then row columns. So we do 331 plus 38. So that gives us 369, and then this is 3, 2, 1, and then 2, 6, 8, 1, 5, 4. So these will be the row total. So row total, right? And now we have no, those are column totals. Sorry, it's columns. Okay, and then now we have row total. Okay, and the row total would be add all these numbers and add all these numbers. Okay, so we got 331 plus 269 plus 238 plus 139. That gives us 977. And the next row we got 38 plus 52 plus 30 plus 15, and then 135. Okay. So now if we add both row and column total, it should give us the same total here if we were to add all numbers up. So we got 135 plus 977. That gives us 1112, 11112. So that is this total of adding this way or adding this way. Okay, either way will work. Okay, so that is how many order in this study, in this survey. So now we are asking, if we select one order randomly, what will be the chance that order we selected is from restaurant A, or that order is accurate? Okay, so the way we do that is we define these events so that way it's easier to apply the rule. A be the order picked or select from restaurant A. So that's the event A. Event B be defined as the order picked or select from, or not from, the order picked is accurate. Okay, so now the question is asking us to find probability of A or B. Okay, so we know it's addition rule because it's a single order being selected and there's a word or. So we're going to say, okay, the rule said we take P of A plus P of B minus P of A and B. Okay, all right. The probability of event A occur if one order is selected. That means what is the chance that the order selected from restaurant A? So all the order from restaurant A is this total here. So we have a 369 possibility of the order select from restaurant A out of all the order from the survey, which is 1,112, plus the probability of event B, meaning what will be the chance or how many possible order can be picked from that is accurate. So these would be all the order that are accurate, 977 over 1,012. Now, if we don't subtract anything, we are going to get the numerator to be bigger than the denominator in this case. If we add them up, we're going to get the numerator exceed the denominator, and that value, that probability is greater than 1, which is not defined as the definition of probability. It has to go from 0 to 1. So we probably double count something, so we're going to subtract that, and that is subtracting the probability of event A and B. How many orders are there? How many orders from restaurant A that is accurate? Well, we just look at the table. We said restaurant A and the order that accurate, so 331. That's what the number we double counted, so we have to subtract one of those. Okay, so now this will give us what? 1,015 over 112. 1,015 divided by 1,012. That is 91%, so 0.913, around there. Right, so we have a 91% chance of picking an order that is from restaurant A or the order is accurate. Okay, and then the following question: are the events of selecting an order from restaurant A and selecting the order an accurate order disjoints? So what that means is, do these two orders have common outcome or not? In other words, this is asking for mutually exclusive. Are they mutually exclusive? Okay, the answer is no. So we said event selecting order from restaurant A and selecting an accurate order is not mutually exclusive because there are 331 orders, 331 accurate order from restaurant A's. Okay. All right, so I'm gonna go ahead and pause on this video, and in the next video, I'm gonna start on the multiplication rule and conditional probability.